on to the last application of distance formula, or Pythagorean theorem, I should say. We're moving on to the last application of Pythagorean theorem, and that is to calculate distance between points. And we're going to make an 8th grade connection. So 8th grade is linear algebra, which means you're dealing with a bunch of lines. So what you're going to have, you got to know how to plot points. So you're going to be given 2 points on a coordinate plane, and you're going to be able to calculate the distance. What I want you to box up is the word distance. And just remember from yesterday, distance really meant the quickest way. So distance is always the quickest. If I say how far are we from Minneapolis, they're not going to take me the back way. The maps isn't going to take me the back way. The maps takes me the quickest way, which means they're going to try to go diagonal. You know, if you try to map Chicago from Minneapolis or Elk River here, it's going to look like a diagonal, so you can make a right triangle. So I do want you to write that down. We did this yesterday too, but it's very important. Distance is diagonal. Diagonal is the hypotenuse. Hypotenuse. Okay? So you're going to always have a diagonal. And what your expectation is going to be is to identify your right triangle. And there's 2 right triangles you could really do, and I'll show you that in a minute. You can either, so a diagonal is the quickest way. You could either make a right triangle by going down and over, or some people go from the bottom up over. It doesn't matter. It will always be the same thing as long as you know how to count and use Pythagoreans. So you're going to create a triangle today. Today you will always be looking for distance, and distance is that diagonal. So you're always going to be looking for the hypotenuse today. Okay, so if I have these 2 points, 3, 4, and 5, 1, and I think you had that on day 1 or day 2 homework. I forget which day you guys had it, but you need to find how far apart they are from each other. So what I do is plot them and make a triangle. So when you plot, you have to remember x, y, and you always start at the origin. So I'm at the middle, and then x is 3, y 4, 1, 2, 3. And then up 4, 1, 2, 3, and 4. And then my next point is 5, 1. So starting at the origin, I go x is 5, y 1. 1, 2, 3, 4, 5, up 1. So if I wanted to scoot from one dot to the next, I'm not going down and over like slow. I'm just cutting through like a diagonal. So what I'm going to do is just show that. We're going to cut through. And don't mind my scaling, it's because they're so close together. But now you have your diagonal, which is the hypotenuse. You have to make a triangle. You have to get from one to the other, which is really connected to slope. You could drop down, go over, or it doesn't matter. You might as well always go left to right, so you don't ever mess that up. But you could also go over, down from the top, or up, over. It doesn't matter. My eyes want to go down, over. So I'm going to go down and over. My triangle is weird, but you should be on the same line as the points are. And then use Pythagoreans. I spot my right angle right there at the corner. So I can count what their dimensions are by counting your squares like slope. So this would be 1, 2, 3. So 3 is my height. And then on the bottom, I have 1, 2. So 3 and 2. So now I have the ones that make the right angle, so I can use Pythagorean to find the hypotenuse, which is distance. So you can go 3 squared plus 2 squared equals c squared. Punching that into your calculator, you get 13. So, right, 9 plus 4 would be 13. So 13 is equal to c squared. And then you got to square root it. So c is square root 13. Let's see if I can even estimate that. Well, 3 point something, 3.7, 3.8, what is it? 3.6. 3.6. C is 3.6. Okay, so we're on to the nearest 10. So 3.6 is the distance. Okay, the distance between those points. What a lot of kids accidentally do, and I've seen it a lot today, as well as with my eighth graders, they try to count diagonals. Don't count diagonals, okay? It's not diagonal, it's Pythagorean. You have to, anytime you see a diagonal and it says far or distance, there's a triangle hidden in there. Okay, now I'm going to do it between the points -2, -3, and 4, 5. So I'm going to go x, y, in my origin, and x is -2, y -3. So 1, 2, and then down 3. 1, 2, and 3, right there. And then 4 and 5. So starting at the origin, 1, 2, 3, 4, up 5. 1, 2, 3, 4, 5. Okay, I kind of like this one more because it's not so smushed together. So now I can make my diagonal because they're not straight across. It's a diagonal, which tells me there's a triangle. And I don't know how you see your triangle. You can see your triangle. I'm going to show you. I'm going to erase a couple things, okay? You can see your triangle like this, up and over. That's fine. That's how you want to see your triangle. Or you can see your triangle like this, over, up, or whatever that is. You see that? I don't know how you see your triangle. It's not going to matter. You can draw your triangle to the left or to the right. It doesn't matter at all. I'm going to use this one. Oh, -2, -3. Okay, I don't know if I'm going to do a good job at this. I don't know if I did it good. Okay, so you let me know if my numbers got messed up with how that moved. So I see 1, 2, 3. Oh no! How many? Is it 7 or
8?
8. 8, and then 1, 2, 3, 4, 5, 6. 8 and 6. And your right angle is right there at the corner. So you just add them and square it. 8 squared plus 6 squared is your distance squared. You can even turn C into D. Variables don't matter.
Or N.
Okay, and then you get 100 is D squared. So how far away? D is square root of 100, which is 10. Okay, we're not done yet. Now we're going to use a really fancy formula. So what some kids did is in second and fourth hour, they noticed the difference between the x's. Because you have an x on the bottom or top in a diagonal, they'd be like, oh, I know what the side would be. It would be the difference of the x's. So they would subtract. They'd say -2 is 6 away from 4, right? Because you have to get to 0 and then 4. So they would turn that to 6. And then they'd say -3 and 5. How many spaces are between them? 8. And then they're like, can I just do that? I said, you sure can. That is actually, when you think like that, is this formula.
Why does it look so complex?
Because it's really, this formula is really this. What this formula is doing is saying subtract your x's, see how far away from each other they are, square it, subtract your y's, see how far away they are from each other, square it. So that would be this one, subtracting your y's, subtracting your x's, add them together. That's what you always do. You always add them together, and then in the end you square root it. That is Pythagorean theorem in one formula. Now, right now. Okay, so here's what I'm going to do. I'm going to show you how to use this fancy formula. So we have xy, and x2 minus x1 just means take away your x's. That's all it means. So I'm going to type it in, square root. It's going to be a big square root. I'm going to type it in exactly how the formula has it. So parenthesis, second x, take away the first x. So 4 minus 1, parenthesis square, that's what it says, plus parenthesis, now subtract your y. Second y, take away the first y. 7 minus 3, parenthesis square. And then I just want to show you, if I can find our calculator. Okay, so help me out here. It's going to be square root. And what was our second x? 4 minus 1. Stop. Second x was 4 minus 1. So parenthesis 4 minus 1 parenthesis square plus parenthesis. 7, second y 7 minus first y 3 parenthesis square. Hit enter and it tells you your dimension. So that is the Pythagorean theorem worked out to one-stop shop. So I type it in exactly how I see it. I want to show you the next one. So this next one I have xy. So according to the distance formula, this is called the distance formula. The distance between these 2 points is equal to creating a right triangle, which means how far apart are your x's, that would give you the bottom dimension. How far apart are your y's, that would give you the tall dimension. And then the hypotenuse is taking the square root of that sum. But you can just use it all at once. And this is the formula you'll get next year on your formula sheet. 8th grade formula sheet has this on it. Okay? So here I go. It would be parentheses second x negative 4 minus first x negative 2 parentheses squared. And you don't even need to turn it to plus plus. Your calculator will do all of that for you. Plus parentheses second y negative 9 minus first y negative 3 parentheses squared. Okay. So you're going to have to kind of help me out because I'm going to forget this in 2 seconds when I bring the calculator up. Okay, so now I'm going to go second square root parenthesis. What was the second x? Negative 4 minus, what's the first x? Negative 2. And don't forget to use the dash down here for the negative or it will say syntax error for you. Parenthesis square plus parenthesis second y. Negative 9 minus first y, negative 3 parentheses square, hit enter, and then it gives me that weird thing, and you want it as a decimal. So this is called 2 root 10, but we don't care. So 6.3, you know I put that. So 6.3 would be the distance between these. Now, here's what you can do today, and this was 5, right? What you can do today is use this formula. It truly is easier. Once you get the hang of it, it really is easier. Or the other thing that you can do is draw a picture. So you have graph, you can Google coordinate plane and you can plot them and make a triangle yourself. Hold on, you need a left-hand side. Don't clean up yet. No, don't get mad at me. Now, on your left-hand side, on that blank line left-hand side, this is going to take me 2 minutes as long as you transition good. I want you to write straight lines. Straight line. Yeah, you do it on the left-hand side. Wow, that's a you problem.
That's it.
Okay. So, a straight line is something like this. Now give yourself a visual. A straight line would be no diagonal. So write no diagonal. I mean, diagonals are straight. So diagonals are straight, except it looks like you can easily create a triangle. A straight line would be straight left and right. Or, so left to right. Or it can just be up and down, vertical. That's what I mean by straight line. Do not use Pythagorean's theorem for exactly straight lines. Okay, don't use Pythagorean's theorem because you wouldn't be able to make a triangle. You wouldn't know where to go. So straight lines, no triangle. Straight lines are just normal. So count normal. So no triangle, you just count normal. And I'm going to give you one little visual. Make a baby coordinate plane. And when I say a baby one, I mean like watch this. Coordinate plane. And then watch 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. So make a 3 by 3 corner plane. But look at what Nate's doing. Let me
She doing that?
look at him being able to
You
think,
should
problem solve. No, because I'm recording. Okay, so here's what we got. You will be given a coordinate plane in a straight line. So what you need to know about a straight line means no diagonal. It's just left or right or up and down. So I'm going to do left to right. So I'm going to go from here to here. And if I say calculate the distance of that, you just count. You don't make a triangle. This is straight. You can't. You have no diagonal to do the C-square. So this is just count. So it would be 1, 2, 3, 4. Do you see how I'm counting? I'm counting the grid marks. It'll be easier when you actually have the real graph. So your distance here is 4. So you need to just make sure to count 1, 2, 3, and 4. You just need to count as normal. So if it's up and down or left to right, you just count normal, okay?
Ironman dies.
Fireman dies.